Hi, this is S.Priyadharshini, working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today, we are going to look into the topic of how HDFS block replication is done and how the read and write technique is done. So, as we all know, HDFS is nothing but Hadoop Distributed File System, which is the main storage component in the Hadoop environment, accompanied with its MapReduce and yarn. So let's see how these data is divided into blocks and how the replication is done in HDFS. So blocks as we know, it is nothing but the smaller continuous location on a hard disk drive where data is generally stored. In general, in any of the file system, we store the data as a collection of blocks. Generally, the user data is stored in the form of HDFS. The files in this file system will be divided into one or more segments and will be stored as an individual data node. These file segments are called as blocks. In other words, the minimum amount of data that HDFS can read or write is called a block. The default block size in Hadoop version 1.0 is 64 MB, but it can be increased as per the need to change in HDFS configuration. So we can change the default block size. In Hadoop version 2.0, the block size would be 128 MB, which is again configurable. Let's see the replication management. HDFS provides a reliable way to store huge data in a distributed environment as data blocks. The blocks are also replicated since to provide the fault tolerant system. The default replication factor is 3, which is again configurable. So let's see an example. Let's take a block 1 which will be replicated 3 times. So block 1, according to rack awareness algorithm, it will be replicated 3 times and will be stored in node 1, 2 and 4. So block 1's replication is done in node 1. Node 1 will take care of replicating again it in node 2, and node 2 will be taking care of replicating block 1 in node 4. Let's see how does it monitors. So there is a continuous heartbeat communication between the data nodes to the name node. If a data node's heartbeat is not heard by the name node, the data node is considered to have failed and is no longer available. So we know how does the HDFS work. So name node and data node are the master slave architecture, where name node is the master architecture and data node is the slave node. So for every 3 seconds, a heartbeat should be sent by the data node to the name node. If the heartbeat is not sent after 3 seconds, the name node decides that the data node is failed and it assumes that it is no longer available. So in this case, a replica is employed to replace the failed node and a change is made to the replication scheme. Let's see how the write architecture is performed. So HDFS follows write once, read many, which is warm philosophy. So we can't edit files already stored in HDFS, but we can append new data by reopening the file. So let's see how the write architecture is performed. So let's take an example.txt, which is 248 MB of size. So here the client will be dividing the file example.txt into 2 blocks, one which is 128 MB, which is block A, and the other one is 120 MB, which is block B. Now let's see the following protocol will be followed whenever the data is written into HDFS. At first, the HDFS client will reach out to the name node for a write request against the 2 blocks, say block A and block B. The name node will then grant the client the write permission and will provide the IP address of the data nodes where the file box will be copied eventually. Then the selection of IP address of data blocks is purely randomized based on availability, replication factor and rack awareness that we have discussed earlier. Let's say here the replication factor is set to default, that is 3. Therefore, for each block, the name node will be providing the client a list of 3 IP addresses of data nodes. The list will be unique for each block. Suppose the name node providing following list of IP addresses to the client. For block A, it will be IP of data node 1, 4 and 6. B, it is node 3, 7 and 9. So each block will be copied into 3 different data nodes to maintain the replication factor consistent throughout the cluster. Now the whole data copy process will happen in 3 stages: setting up of Flame, streaming the block and replication, shutting down of the Flame, and acknowledgement stage. So the first stage is setup of pipeline. Before writing the blocks, the client confirms whether the data nodes present in each of the list of IPs are ready to receive the data